Welcome to our well, is it really our final test review? No, but it is the final normal test review. So welcome to your final normal test review before we start getting, say, videos on the final semester exam review, which would be the final review. Yeah, go with that. Anyways, so this is the Unit 14 review. And everything will be posted up on my video channel, which you would have already seen by now. But anyways, whatever. So let me go ahead and show you the answer key for the review. If you want to work off just that, that'll be fine. That can kind of shorten things up a bit. Or, listen to the rest of the video and, hey, my feelings will not be hurt. Alright. Okay, so here are the answers for the first two. Moving on to the next ones. Here are the answers for 3, 4, and 5. If you need to make sure, pause me when you need to. Alright, so here are the answers for 5 and 6. 7 and 8. 9 and 10. Okay, keep in mind that I'm going to want the LCM and this in like these type of problems. Whoops, right over here. Okay, so here's the answers for number 11. Do I have anything else? Nope, sorry. 12, 13, and 15. And then finally there's number 14. So there are all your answers. Now let's go through each and every single problem one by one. Alright, so here's number 1. What I would do on this is, one, you got to start factoring. Don't worry about the 24 and 32 yet, but you do need to factor the x squared minus 36. That one's the difference of two squares because you can take the square root of 36. So when you can do something like that and you see x squared minus a number, you see if you can take the square root and you can go, oh, I can, so that's x plus, x minus 6, because the square root of 36 is 6. But if you look at the other one, x squared minus 6x, I can see there that's a greatest common factor because they both have an x, so I can take out an x and I would be left with an x plus 6. I'm sorry, x minus 6. So if you put all that together, that would give you 24x and then x minus 6. And then on the bottom, I would have 32, x plus 6, x minus 6. Notice I like to put the numbers in front. So the x, in this case, this is just simplifying. So that means, what can I cross out? I can cross out the x minus 6's, and that's really it. Now, for full credit, though, I would like you to look at the 24 and 32. You could type that in the calculator and say 24 divided by 32 and press enter. And if you do, you would get 3 over 4. So then I can put 3 over 4, 3 with the x, and 4 with the x plus 6, and I'm done. That's my answer. Bam! Bada bing, bada boom, there you go. Okay, number 2, the first one that I'm going to look at is the x squared plus 11x plus 28, which would be plus plus. And two numbers that multiply to give me 28 and add up to 11 would be 7 and 4. 7 times 4 is 28, 7 plus 4 is 11. So remember, the two numbers multiply to give you the one in the end, and they should add to give you, or subtract to give you the number in the middle. The bottom one, I can see there's a greatest common factor of x, so I can take out an x, and I would be left with an x plus 7. Now, on the second part, when you have to divide, remember, those two flip. So the 5x squared minus 35x is actually going to be on top, and I'm going to factor that. So I'm going to work that one first and just flip them as I do that. I have a greatest common factor of 5x, so I divide them out, take out a 5x, and that would leave me with x minus 7. And then I would take out on the bottom, or the 3x plus 12, which is going to go to the bottom. I could factor out a 3 and a 12, or I could factor out a 3, which means I'm dividing everything by 3. That would leave me with an x plus 4. Then I can combine that all together and then see what crosses out, such as the x minus 4s, or the x plus 7s. Now, here's where most of y'all messed up. And I mean, you would get partial credit, of course, but keep in mind, the x's, even though that top one says 5x, I mean, you can think of that as being like by itself. So that can cross out with that x here at the bottom. And that would leave me with a 5, x minus 7 over 3. And there's your answer. See, not that bad, right? On number 3, we are adding and subtracting. Now, if they have the same denominator, which they do on number 3 and number 4, all you got to do is combine your like terms. Well, what can I combine with the 5x and 11x? So 5x plus 11x is 16x. There's nothing to go with the 2x squared or the minus 5, so I just write those together. And that's it. I actually have no idea what's being added here. Okay, don't even worry about that. Now, on this one, keep in mind that minus. That minus, you've got to read it correctly. So, like here, I need to say, like, what is 6x minus 2x squared? Or 6x squared minus 2x squared. So, what's 6 minus 2? 4x squared. And then, I've got to say, like, what is negative 12x minus 3? Negative 12 minus 3 is negative 15x. And then, I gotta be careful here. 25 minus a negative 15. So 25 minus a negative 15 would give me a plus 40. And that would be it. So you can see there on those type of problems, and you will get a couple of those, all you gotta do is make sure, one, combine your like terms, but two, just kind of go like this minus this and follow what it says. Like the first thing in the first one, plus or minus this, whatever it is like it in the second one. And that should hopefully be fairly easy. Alright, number 5 and number 6, though, they don't have like terms. So what do? Well, first off, is there anything they have in common? Okay, on number 5, you can see both fractions have a 3. So write the 3. Then, what can I add from this first fraction? I can add an x minus 1. What can I add from the second fraction? I can add an x plus 4. So that right there makes up what is called my common denominator, which will also be your LCM, your least common multiple. Alright, so if you notice, I have these 3 things in the denominator, and I only have 2 of them in the first fraction. So what's missing? The x plus 4. So I need to multiply 5 times x plus 4, which would be 5x plus 20. The second fraction is missing that x minus 1, so I'm going to multiply the 11 by x minus 1, which would give me 11x minus 11. So now I can go, okay, what are my like terms? Well, 5x plus 11x gives me 16x. 20 minus 11 is 9. And you're done. On the bottom one, number 6, they have an x plus 3 in common. And then I can add an x minus 3 and an x minus 7 from the other 2 fractions. Or from the 2 fractions. So, now, where I would be careful is that minus and then divide by 4, I would change that to, I'll get to that in a second, I guess. So what's missing in the first fraction? The first fraction is missing that x minus 7. So I'm going to say 9 times x minus 7, which is 9x minus 63. I would change that minus to be plus negative 4 and multiply that to the negative 3, or x minus 3, to get negative 4x plus 12. So you might want to make sure you're careful with that. 9x minus 4x is 5x. Negative 63 minus or plus 12 is negative 51. And you're done. That's it. That's all you got to do. I know, easy peasy, right? Okay, 7 through 11, I'm going to want you to make sure you find the LCM and give me the answer. Now, hopefully the LCM is fairly easy, especially when things are factored. You can see the individual elements. So, do they have anything in common, the fractions? No. So I just got to say, okay, the LCM is d plus 1, d minus 2. That's it. That's your LCM. You take the 2 denominators and that becomes your LCM. Now you're going to multiply those to the numerators, or the fractions. So like here on the first one, the d plus 1s would cancel each other out, leaving you 2 times d minus 2, which would be 2d minus 4. The second one would be the d minus 2s would cancel out, leaving me 1 times d plus 1, which is 1d plus 1. And then, like I like to say, variables to the left, numbers to the right. You know, change your signs and combine your terms. And then after that, if you need to divide, you divide. And that's it. On number 8, you can see here, the first term, the 2, does not have a fraction. So ignore that. You look at the ones with the fractions, and you build your LCM off of that. So there's an LCM, there's a 2 in the denominator, and there's a q plus 3 in the denominator. So that's my LCM. And when I multiply the first one by that, there is nothing in the there is no denominator to get rid of the 2, because you can only cancel in the denominators. You can only cancel here. Okay? So if you don't have a denominator, you just multiply. 2 times 2 is 4. 4 times q is 4q. 4 times 3 is 12. In this next term, the 2's would cancel out, leaving me a q plus 3 times the 5, which would be 5q plus 15. And then the last term, the q plus 3's cancel out, leaving me 2 times 2q, which is 4q. Then I can combine like terms. That would give me 5q plus 4q is 9q. And then I can say variables to the left, numbers to the right, minus 9, minus 12, and get negative 5q equals 3, and then divide by negative 5. Again, that right there is fairly simple stuff. The main new thing is how do I get rid of those fractions. Okay, on number 9, I might do this, I might not, but like you see on number 9, and this is where you got to be careful. You got to realize that 10 is like 5 times 2. So, like from the first fraction I can get an x, from the second fraction I can get a 5 and a 2, and from the third fraction I can get a 5, which I already have, so I don't have to write it again. So now if I multiply x times, like the x times the 5 plus times the 2 to the whole thing, like so, the x's here would cancel out, leave me 5 times 2, which is 10, and 10 times 14, which is 140. And then here, the 5 and the 2 would cancel out with the 5 and 2 here, leave me 3 times x, which is 3x. And then on the last one, the 5's would cancel out, leave me 3 times x times 2, which would be 6x. I guess I did that there. That's a mess. Anyways, and then from there, I can say, oh, let me just go ahead and move the 3x over this way, and say 6 minus 3x is 100 is 3x, and then I would have that equal to 140, and then I can divide by 3 because I'm trying to solve for x, and that ends up leaving me 140 over 3. And you're done. That's it for that one. I know, these aren't so bad, right? Right. Oh, by the way, I should probably sneak in a secret word in here somewhere, so I'm going to go ahead and do it with this next one. So let's go ahead and say the secret word is, do I feel like I'm in dynamo mood, a rocket mood, or an Astros mood? Don't want to jinx something, so let's just go with red. Right? Let's say, we'll go with red. Your secret word is just the word red. Alright? Anyways, on this one right here, I would probably change this to where I would just give it to you as individual elements. So instead of saying n squared minus 4, I'll give you the n plus 2, n minus 1. I'm sorry, n minus 2. And then your LCM from the first fraction is n plus 2. From the second fraction is n minus 2. And so when you multiply those to the different fractions, the n plus 2's would cancel out, leaving you 1 times n minus 2, which is n minus 2. The n minus 2's would cancel, leaving you n plus 2 times 1. And then everything cancels in the last one, leaving you just 3. Seems kind of weird to say, oh, it just leaves you just 3. But why not? Anyways, so here I've got n plus n is 2n. Negative 2 plus 2 is 0, so that cancels out. And then I'm left with a 3. I can divide by 2, and so n is equal to 3 halves. All done, easy peasy, there you go. Alright, so now let's look at number 11. Alright, so now let's look at number 11. Like I said, I won't give it to you like this. I would give it to you in this individual elements. In this case, this one would have been a factor of k minus 4, k minus 3, or k minus 3, k minus 4. It really doesn't matter. Either way, from the first fraction, I can get k minus 3. From the second fraction, I can get k minus 4. And in the third fraction, I already have both those elements, so that's my LCM. Done. Happy joy. So now I'm going to multiply each one of these by k minus 3, k minus 4. So in this one, the k minus 3's would cross out on the first fraction, and I would be left with 3 times k minus 4, which is 3k minus 12. On the second one, the k minus 4's would cross out, leaving me 4 times k minus 3, which would be 4k minus 12. And on the final one, the k minus 3 and the k minus 4 cross out, leaving me just 25. Combine your like terms, you've got 7k minus 24 equals 25. And then I can say move the 24 to the other side. I would get 7k equals 49. And then I can divide by 7 to get k equals 7. Oh, it's easy. Not so bad. I know, this is actually pretty good, right? Anyways, so let's go to the next part and let's look at the back half, or the back problems, numbers 12 through 15. Okay, so remember on 12 and 13, those type of problems, when there's no factors in both the numerator and denominators, it's just a factor, it's just like a factor in the denominator, then you don't have any wholes or zeros, so those would be NA. And the vertical asymptote would be the opposite of whatever's with the x, so x minus 3, the opposite of that would be positive 3. And then the horizontal asymptote would be the number after the fraction, exactly as it is. So the horizontal asymptote would be y equals 2. And then your domains and ranges are all reals, but again, it won't equal the 3 or the 2 from the vertical and horizontal asymptotes. Now, be careful on number 13. Don't worry about that. On 13, notice that there's just an x by itself. So that one, since there's no plus or minus with it, we're going to put 0. And the horizontal asymptote would be at negative 5. So I got a 0 here. I guess I'd wanted to put everything there. And then the horizontal would be at negative 5. And again, notice how the domain and ranges kind of matches that. On 14 and 15, you've got to be able to say factor. So there, like say plus plus. Just a minute. Okay, so here's a chart again. Don't forget how we need to factor. We got to see first if there's a GCF, a greatest common factor, to take out. Then we can worry about quadratic factoring. And then maybe you get difference of two squares, which again is like x squared minus a number. If you can take the square root of the number, then it would become, the square would be the numbers in the parentheses. Anyways, let's look at 14. So according to this, I would be able to go plus plus is plus plus. Two numbers that multiply to give me 2 and add up to 3 are 2 and 1. And on the bottom, I've got minus minus, which is minus plus. Two numbers that multiply to give me 3 and subtract to give me a 2 are 3 and 1. So you can see here, based on this, with it factored out, which that would probably be an answer, I can go, okay, so let me find the vertical, the horizontal, the wholes, the zeros, all of that. In this case, again, remember, the zeros are what crosses out, so the x plus 1s make up the zeros, and the opposite of a plus 1 is negative 1. The leftover on the bottom makes up the vertical asymptote, so x minus 3 would make up the vertical asymptote, which would give me positive 3. The zeros would be the one on top, the x plus 2, and the opposite of that is going to be negative 2. And then for the horizontal, we look at the first term, go back to this in the beginning. The numerator and denominator are even degrees, so the degrees are the same. So I look at the numbers in front and then divide. 1 divided by 1 is 1. And then you can do your domain and you can do your range. Okay, and kind of go from there. On 15, I'll just go ahead and put it here. Minus minus is a minus plus. I'm looking for two numbers that multiply to give me 15 and subtract to give me a 2, which would be 5 and 3. On the bottom, I've got a greatest common factor, so I can take out an x, and I would be left with an x minus 5. So the x minus 5's cross out. That would be my whole. So that would give me that my whole is at 5. X equals 5. I would have an x left over. So my vertical asymptote would be at 0 because of the x that is left over. And then the zeros would be at the x plus 3, which the opposite of that would be negative 3. And again, because my degrees are the same, 1 divided by 1 is 1 for the horizontal asymptote. And there's my domain and range again. So keep in mind, again, if the degree, the exponent for the beginning, if the numerator one is bigger, there is no HA. There is no horizontal asymptote. That means you would put NA. If it's smaller, it's always equal to 0. And if they're equal, you look at the numbers at the beginning, and then you just divide them. Anyways, I've gone on for quite some time here. That's it for today. Good luck. I hope y'all are really well prepared for the test. And that's it. Y'all take care. Thank you so much for your time.